problems. These things are tricky for sure. And every one of them is different. So we just have to think about all the problems we've done in the past. What are some of the things we've done? Okay. All right, so let's take a look at problem A. This is 1A on practice test 3. What do you think we ought to do? Difference of squares. Very, very good.
Good job, Mary.
Difference of squares.
Very, very good.
Okay, how does the difference of squares factor? There on the numerator, that is the difference of squares. How does it factor? 3 minus sine x, 3 plus sine x. So, if that had been a 16, or a 25, or something like that, I would do exactly the same thing. It's the difference of squares. Now, the minute you do that, what do you notice? These are the same, aren't they? So your job was to simplify. This is it. That's what it simplifies down to. That's it. That's all there is to it. What about this one? What pops into your head when you see this as an option? What are some things we might consider doing? What? Sometimes we factor. We can't factor anything there because nothing matches. What do you think? Oh, we can rewrite this in extraction form, right? So cosine doesn't get changed, but this does. What is cotangent? Cosine over sine. You will have your little half reference sheet. Plus, and this is just sine over 1. Now, be very, very careful. Can I cancel these? No, because that is a plus, and I can only cancel when it's a times, okay? Does anything, this is a times, does anything here cancel? No. I have cosine squared over sine. Nothing cancels. Plus sine over 1. Now what do you notice, or what do you think? Maybe. Aren't these both fractions? And they're added? How do we add fractions? We get a common denominator. So what will our common denominator be? Sine x. This one already has it. This one needs it. So I'm going to multiply the top and the bottom by the sine. Now, they have the common denominator, right? So I can add them together. And what am I going to have on the top? Cosine squared plus sine squared, which is 1. And what is 1 over sine? Remember, we're not leaving 1 over. We're going to write it as what it is. What's 1 over sine? Cosine. So, again, every problem like this is going to be different. But let's talk about some of the things we did in these two. First of all, we factored, and we factored particularly the difference of squares in this problem. And then we pretty much were done. Here we changed into our fraction form, Remember, we can change anything into a fraction except sine and cosine. They just stay the same. Sine over 1, cosine over 1, but everything else can change. Then we get a common denominator and added, and then we noticed we had a 1 there. That was on our reference sheet. Okay? All right. Number 2, switching gears. By the way, the test is going to have 2 problems like this on it. I don't want you to freak out. These are the hard ones, for sure. You got the whole rest of the test you need to worry about too. So make sure that you're not spending all your time, if you choose to study, make sure you're not spending all your time on those 2 problems, because you want to know how to do the rest of the stuff too. All right, so what do we got? Solve the following triangle. All right, we know what that means. That means find everything that is missing. All right, so what do we know? We got A, B, C. All right, so what do you notice right off the bat? Easy, easy points. What do you notice? We can definitely find angle A. So let's see, would angle A be 80? You're gonna have to help me out because I gave my calculator away, is that right? Yeah. Okay, now, the minute you wrote that 80 down, do you notice this right here? So what's that your clue? That's your clue that you're gonna use the law of sines. So sine 80 over 10 equals, I don't know, sine 53 over C. But you're also going to be doing sine 80 over 10 equals sine 47 over B. You're going to do both. And the order you do it doesn't matter. Okay? So once you get your proportions set up, you're going to cross multiply. And you're going to divide. And you're going to type it in. And you're going to do that for both of them. On this particular problem, am I going to do any inverse going on here? No. When do I do inverse? If I'm finding an angle. If I'm not finding an angle, then I just type it straight in. So did anyone do that? What did you get for C, side C?
8.11.
What?
8.11.
8.11? Yeah. And what did you get for side B? 7.43. Right, again, I gave my calculator away, so I have no idea. Are those correct? No?
Yeah, thanks, sir.
Anybody have a question? Okay. Got it? All right. I think there's another solve the triangle. So this time we got a 42, 18, 23. All right. This one starts out exactly the way your quiz started. Because the first thing you're going to find is side D. And how are we going to find side D? How did you do it on your quiz? Law of cosines.
D squared.
So D squared. Now here it's going to be cosine 42. And what's all this stuff in the middle here? 18 squared. Plus 23 squared. Minus 2 times times 18 times 23 times cosine 42. Does everybody see why I'm not using the law of sines? Remember, to use the law of sines, we have to have this, and I don't. So it's gotta be a law of cosines problem. I know I'm gonna use angle 42, so d squared. Now, when you type all that in, be careful, because that is d squared. So, square root it. Anybody have a d? 15.42. Willow, 15.42. Now on the quiz, you were done with that problem, because all you had to do was find side D. But this question on the test is find everything. So now I have to find maybe angle F. What am I gonna do to find angle F? Well, did you notice what you've got now? So we can set up our law of sines. Sine 42 over 15.42 equals sine F over 18. And the minute I write that, I know eventually I'm going to be doing inverse because I'm looking for an angle. Right, but first I'll cross multiply. And before school, a couple kids said, you know, they typed this in and they said, Miss Ford, I got this decimal and I know that's not right. Yes, this is going to be a decimal. To get your angle, you're going to have to inverse sine that, right? Second sine that. The decimal is not, excuse me, the answer.
51.36.
Well, I heard 51.36.
36.
That what you got?
Yeah.
Okay. Now you got it made in the shade, folks, because now you have two angles. So we'll just add them up and subtract from 180, 86.64. Oh, help me, is that right?
Yes.
And that triangle is solved. Okay? Part 3. How many triangles are possible? We're going to be sure we're showing our work. How many triangles are possible? All right, so what am I going to, how am I going to start? This is problem 3A.
Sine 58.
Yep.
Over what, Jarius?
16.
16, yep, equals
Wait.
sine
It
C
says 6
over.
Wait, where you get 16 from?
We have 6 on our page.
Oh, I'm sorry, it is a 6. Sorry. All right, now we cross multiply. And once again, notice,
Inverse?
what are we gonna have to do?
Inverse.
Inverse, you're gonna have to inverse. Anytime it's sine C, or sine F, or cosine A, you know you're gonna have to
I
inverse.
got an error.
Uh-oh, Willow got an error.
Does that mean 0?
Listen, you and Jarius can't both be wrong, so there you go. No triangles possible. No triangles possible. When they type this in right here, and inverse signed it, it said error. All right. Are we still discussing this? Are we clear on this one? Are we moving on to the next one? We okay? Everybody get error? Okay, so I've got the next one set up. It's the same thing. Sine 62 over 19 equals sine C over 12. So you're going to do your cross multiply. You're going to have to do an inverse again.
$39.
33.90?
No, 89.
89? We don't really care that much about that particular answer, because what are we trying to do? Figure out whether we have one or two triangles, right? So we definitely have one. We got an angle here. Did everyone get 33? Okay, so then remember what we do. Over to the side or somewhere, we redraw the same exact triangle, recognizing there could be a second answer.
Is it 190 minus?
And if there is, it's gonna be 180 minus 33.89. So that would be 146.11 if I subtract it right. Is that possible? Can you have your original 62 and 146? No. So therefore, how many triangles are possible? One. Just the original one you got with the 33. So same exact setup. We're gonna cross multiply. And just like usual, because it's sine C,
At a high school reunion.
you are going to inverse it. Charles, you okay back there, honey?
52.21.
What?
52.21.
52.21, do I have confirmation from somebody? Yes? All right, so once again, we gotta figure out, can I have another triangle possible, still with the 45, but now with 180 minus 52.21?
Yes.
127.79.
127.79? Can you have a 127 and a 45 in the same triangle?
Yes.
Yeah, you can. Right? You couldn't do this one because 62 and 146 is more than 180 and that's not possible. But this one's okay because if I add those together, or not those two, these two, if I add these together, I only get 170 something. So that's good. So this one has two triangles. Anybody have a question about that section? All right, now we have our area problems. And we talked about this last time. And I think I talked about it in the video too. There's 3 of these problems. You're gonna be doing 3 area problems. 2 of them are going to be super simple. 2 of them are just automatic almost. So looking at the triangles, which 2 do you think are the easy ones? A and B.
A and B.
A and B, this is problem B, is so simple. Because area is 1/2 1811 sine 41. 1/2 side, side, sine. Is everyone okay with that? This is problem B. You better not miss problem B. 1/2
Problem A.
side, side, sine. What is it?
I think you missed problem
This is problem B.
A.
Well, I'll do A in a minute. What's B?
Oh, 64.95.
64.95. Is everyone okay with that? 64.95? Now, A is also easy, but you have to do a little work with A. The area will be a big radical with 4 numbers underneath it.
11.
The first number you're gonna start with is half
Of the perimeter.
of the perimeter, okay? So what's your perimeter? Add these up,
22.
22. Don't put 22 in your radical, you put half of it in the radical. It's called the semi-perimeter. Then, what goes in the rest of the spots? 11 minus each of these,
4, 2, and 5.
okay? So we're gonna have 5 and 4 and 2. Now, I've graded so many papers over these many years. I know what kids are gonna try to do. You're gonna add up all the sides, you're gonna get 22, and you're gonna put 22 in the formula. No, 22 doesn't go in the formula. Also, these numbers don't go in the formula. These numbers don't go in the formula. You have to take half your perimeter and then subtract each of those. Type it all up, square root it, what do you get?
20.98.
20.98. Does anybody have a question about those two? Those are the easy ones. All right, now what about this last one? What makes it is not hard, but what makes it harder? What do I not have that I sure do wish I had? Do I need another side,
Would be 55.
right?
55.
I need another side. You've already figured out I got another angle up here that's 65. Did you agree with that?
55.
55. That doesn't help me, I mean, in terms of area, right? I need another side to find the area. But I might use that 55 in a minute. What side do you want to find? It doesn't matter. Which one? L. So this would be side L.
For ley line.
That's side L. So, well, how am I gonna find side L? Sine 67 over 15, did you notice this right here? Equals sine 58 over L. So, L sine 67 equals 15 sine 58. So L, cross multiplying and dividing. Will I be inverse signing in this problem? No. I only inverse sign if it says sine L. Then I need the inverse sign.
13.
This is just to type it in.
13.82.
13.82. Can someone confirm that?
Confirm.
13.82?
Confirm.
Now, why did we do that? So now we have two sides and the angle in between. So remember, we were finding area. So area will be 1/2, 15, 13.82, sine 55. I know it gets confusing using sines and cosines. Remember your formula, 1/2 side, sine. SSS, 1/2 side, sine is your area formula. So what did you come up with when you typed all that in? 84.91? Anybody have a question about that? Okay, last page. Our word problems. Let's see. All right, number one, part 5, number 1. We have a parallelogram.
We're definitely here.
Every practice test has had a parallelogram problem on it.
I'm not learning another lesson.
Well,
Yes, ma'am.
find the length of the shorter diagonal whose sides are 18 and 14. And the larger angle is 124. And I want to find the shorter diagonal.
Cut it in.
All right, so which diagonal is the short one? This number 1 or number 2? Number 1, number 2. Which one's shorter? 2. Find the length of the shorter diagonal. Now here's another place, no matter how many times I tell you, somebody's gonna say, oh, that's 62 and that's 62. No. That whole angle is 124, but I have no idea how it's been split. I do know how big this angle is though. How big is that angle? 56. And why is it 56? Because these two add up to 180. So don't try to use the 124, guys. You're not going to be able to. You can't. Forget about him for a second. Use the 56. You are not doing area. You are finding the length of that diagonal. So take a look at your triangle. Is it going to be law sines or law cosines? It's got to be cosines. Why does it have to be cosines? Because I don't have this, or this, or this. So what will the law of cosines look like for that problem? X squared. 14 squared. And we can type all this in.
200.
But be careful, what do we have to remember to do after we type it all in? We have to remember to square root it, right? 18 point,
15.43.
15.43. And our word problems, we'll put a unit on it, so that would be inches. Anybody have a question about that? Number 2 says we have the same parallelogram. So 14, 18, 124, 56. And we're going to find the area of that parallelogram. So can we actually split it the same way we did before? Can I go ahead and draw that in at diagonal again? Can I find the area of this triangle right here? How would I find the area of that triangle? 1/2, 14, 18, sine 56. 1/2 side, sine. And then, whatever that is, you need to double it, because there's 2 triangles to make up the whole figure. So Evan got 208.92. And that would be square inches. How does that look? Did anyone else get that? Look good? All right, number 3, find the, this is different. Find the perimeter of a regular octagon. So what does octagon mean? H. So there's my octagon with a radius of 22. So remember what we do here, or really it doesn't matter. I like to make a triangle, and it doesn't hurt me to make all the triangles, so you don't have to do that at all. I know every one of those little radii that I just drew in is 22, right? Now what else do I know? I know that angle. That angle's 45. How do I know that angle's 45? Because it's 360 divided by 8 this time, so this is 45. Now, we're doing perimeter. In a minute, problem number 4, we're going to do area. But right now we're doing number 3, which is perimeter. What does perimeter mean? Add up all the sides. So don't I need to find this right here? There's 8 of those, so once I find that, I will be able to multiply by 8 and have my perimeter. Remember, that's a side of this triangle. So to find a side, you're either going to do law of sines or cosines. What do you think for this one? Cosines. X squared equals 22 squared plus 22 squared minus 2 times 22 cosine 45. Why am I doing cosines? Because I don't have a pair. So I've got 2 sides, got my angle, type it all in. And then hit square root. Can someone tell me what you got when you hit square root? 16 point something? Anybody else get that? Okay, now don't write that down though, because that is just this. We want the whole perimeter, so you're gonna say times 8? So the perimeter is 134.70 centimeters. Is that what you got? Yeah. All right, and then question number 4 says find the area. We can do this because we got the picture already drawn. What is the area of that triangle? The area of the triangle would be what? 1/2 22, 22, sine 45, guys, check out. 1/2, side, sine. But again, just like before, once you get that, we don't square root
Times it
that.
by 8.
We times it by 8. We multiply that by 8.
1,368.
1,000.
96.
1,368, and that would be square centimeters. Did you get that?
Yeah.
Wow. Okay, that's it for practice test 3.
Yeah.
So make sure you have, I gave you, when I handed out all this stuff, at the beginning of the unit, I gave you an extra practice packet. Make sure you have that with you tomorrow. We're gonna do more practice tomorrow, yeah. Practicing one more time.